we apply the prediction of land use land cover classification map. So I will explain all of these things one by one, and I will show you all of algorithm or method. Okay? And further, I will apply this method or algorithm for your region of interest. So let me share my screen. Can you see the screen?
Yes, sir.
Okay. Okay. So basically, it's one kind of paper. In this paper, they are explain about the method or flow chart, how we can easily predict, and further how we can easily make the land use land cover prediction for the future. So here you can see this is the one kind of algorithm. Basically, they are used at the GIS software, but in this case, we are used at the Google Earth engine, and further we try to predict the land use land cover classification map. So
Okay,
in
sir.
this case, here you can see. So basically, in this time, we already make the land use land cover map. We already preparation. We already make the land use land cover map, and now we need to create some factor. Okay, suppose this is the input data we need to create, such as this time for this model, their input year of 2012 and 2022 for the land use land cover, 2 decade data they are input in here. Further, they are also input the DEM data, then slope data, aspect data, distance from major road, distance from water bodies, and also population density. Okay, so this type of factor they are apply their model as the input, and further they are make the land use land cover classification map. So today's session I will try to explain about that how we can easily create this type of input, and further I also take the another class, which class I will show you that prediction work. So today's session we talk about that how we can easily create this type of input, and in this input we already created the two land use land cover map. We already created year of 2014 and 2024 we already made. So
Okay,
today's
okay.
session I discuss about the DEM, slope, aspect, distance from major roads, distance from water bodies, and population density, how we can easily create for your own study area. Okay. So let's go. So let me open a new code editor and try to make all of factor. Further, I also take the another class for prediction. Okay, so this session we take about that prediction factor. Okay, this type of prediction factor we need when you want to make the land use land cover future prediction map. Okay, so first of all, I try to import your study area. So basically, in this case, I simply call my dataset. So this dataset provide you your, you can see this the dataset about that secondary level administration area. So from this, we can easily get your study area boundary shape file. So I simply import this boundary area shape file, and further, I take a variable. Suppose I put the variable name is that ROI, or you can put any name as a variable. I put the variable name suppose ROI, and then this table I simply filter, just a table, then I filter it. I filter it at engine dot filter dot equal. So now what's equal what? We can easily get this solution from here. They already provide some table schema for filtering your study area. This time here you can see I just choose the administration level 2. So these things I simply copy and further I paste here, and then give a name. Basically I put the name is that Jaipur. Yeah, Jaipur.
So how can we get this var table? This is import. After import, there is a var table. How can we use this? A var table. How can we get this?
Which one?
This one. Uh, the second line, second. This one. Var table, colon table, FAO, gol, simplified.
So in this case, we simply filtering your study area. Okay, so we find out that your study area Jaipur.
How can we
Jaipur
get
is,
this, sir? How can we get this?
so it's your name, your study area name.
So this is study area name, but what I am talking about this line, this var table. colon table FAQ just before.
So this is a table. This table stored the all of district boundary or province
How can
boundary.
how can you paste this particular URL in this place? You are showing some tables in these this when you place this particular.
Okay, so basically there is no table about that. So this is the variable name table. Okay, so it's a variable name. This variable name is simply put in here table.
Okay.
So this table we filter and further we select admin label to name equal to Jaipur. So now this variable stored the Jaipur boundary. So now we try to add it. So map dot add layer and then put at the ROI. So now it added the layer, okay, but not focus on the center of this boundary shape file. So just we simply write the code map dot center object. Object is my ROI, which stored the Jaipur boundary. So now it visualize your Jaipur boundary. So you can easily get the Jaipur boundary. So this is our Jaipur boundary. So basically this is our study area. And for this study area, we already create two land use, land cover classification map. So these two map I already import in my asset tab. So one is the 2014, another is that 2024. Okay, so this is the 2014, and another is that 2024. I already export and import in my art engine. So I put the name LULC 2024, and another is that LULC 2024 and 14. Okay, so just we simply imported the 2 decade land use land cover classification map. Okay, so now we also need to create this type of factor. So as you can see, we need the dim, then slope, aspect, distance from road, and distance from water bodies, and population. So this type of factor we need to create in this time. So let's go. So in this time I just put here one data set. It's called the DEM data. So DEM data mainly it's provide the digital elevation model, okay, and it's provide the different types satellite imagery. So mainly we are using the NASA SRTM DEM data. Okay, so NASA SRTM DEM data mainly provide the 30-meter resolution elevation. We can get the result in meter, and further can easily use it. Here you can see this is the data set. It's the NASA SRTM digital elevation 30-meter resolution data, and this data set we can easily find out the DEM. Okay, DEM mainly elevation. Where is the high elevation, where is the low elevation? You can easily get it using this data. So just simply import this data. I simply import it, and you can see it will be imported, and variable name is the image. Okay, so now just take a variable. I put the variable name such as DEM. You can put any name as a variable DEM. I call my image. So basically this image stored the DEM data, and further clip with my shapefile, which is ROI. So now further just put here map.add layer and call the DEM and click the run. So now this DEM data is added with your shapefile Jaipur. We can got this type of result. Okay, it shows this type of gray color. But further we also add the color, then we can easily find out where is the high elevation, where is the low elevation. We can easily get it. So just I simply stressing 98%, and further the plated.
Sir, why we use DEM data?
In this time we are also use this type of model. Okay, so basically land use land cover prediction, it's depends some factor such as population factor, distance from road factor, distance from water body factors, then DEM or elevation. Suppose you can easily thought about that high elevation or hilly region, people not settled, or people don't make the settlement for the high elevation. Okay, people always try to make the tendency the lower or flat region. Suppose if you have a flat region and you also have the another hilly region, so which one you prefer, flat region or hilly region? Must be flat region. Okay, so people, that's why it's a one kind of very important factor for making the or settlement. Okay, and also slope is indicating about that. Okay, so you also try to read the paper. Okay, without paper you cannot get the concept because you are not the background of the geography and environment. So that's why you face this type of problem. Okay, so basically this type of things we are already completed. So 1 level, 2 level students already completed this type of topic. So as you have the another background, so this type of you can understand this type of term. We also try to read this paper, then I hope you can get this idea and how it will be work and what is the meaning about the dam, slope, aspect, distance from road, distance from just everything you can get it. So you also try to study more about that. So in this case, I will show you that application or work.
Okay, okay. Kindly send this particular paper link.
Okay, you can get lot of paper you already published, lot of paper. So now we try to add here. Suppose I show the lower elevation, so as I suppose this type of blue color. Then I show suppose this type of green color. Then I want to show this type of yellow color or any color you can choose. And high elevation, I want to show this type of yellow color. So yellow is indicating the high elevation and blue is indicating the low elevation for your study area. So now I try to apply it. So now you can easily get this visualization. So this type of blue color, you can see this type of red color, it's indicating about the high elevation. Okay, and this type of blue color indicating about low elevation. Yellow is the medium. Okay, green is also low. Okay, we can get a map. It's our dam map. Okay, so this we can easily find out the dam map. Okay, so now further. Okay, so further simply import. Click on the import and copy this visualization, this variable copy. So I think if you can't get the code, don't worry. You try to focus on your result. Okay, basically for the getting this understanding this type of code, first of all you need to learn about the basic Google Earth engine or basic Google Earth engine. Then you can easily get this idea, this type of code. So in this case, you try to focus on your result. Then it also more better. So I put the layer name, suppose dem. So now you can see we can easily create one map for our dam. Okay, dam mainly elevation. You find out that this type of red color indicating the high elevation. This type of red color. If you want to check it, suppose click on the Explorer tab and click on your map. Suppose I just click on the this type of red color. I simply remove. Just click on here. Then you can easily find out that you can see 544 meters elevation. You can find out. Suppose I click on here and this unit is the meter. You can see 713 elevation, so very very high. If I check this type of blue color, then you can check about the elevation. We find out the 282 meters elevation. So this is your elevation map. And for the population settlement or other types of land use land cover, it's totally different type of dam data. Okay, suppose land use land cover or build up area or settlement, suppose maximum people all of is just simply try to choose the flat region, not much the high elevation or other things. Not okay. So in this case, if you want to check your land use land cover map, then we find out that maximum place. We find out this type of flat place or this type of flat region. We find out the cropland or other things. Okay, or also a build up or settlement. We can find out this type of flat region. Okay, but this type of red color which is indicating about the high elevation. In this high elevation, we cannot find out this type of settlement or this type of cropland. We don't find out in the high elevation or hilly region. We don't find. Okay, so this is our dam. We can easily create one factor. Then we talk about that. Suppose slope. Okay, so you can see this another factor is the slope. So now what is the slope? Slope is one kind of inclination or gradient. Gradient mainly suppose in the high from your region to flat, how much angle we find out. It indicating the inclination or height, okay, or angle from the flat surface or sea level. From the sea level, we can easily find out the angle, how much angle it is. We can get it using the slope. So I create the slope. Let's put here that slope, and I call the image. Just I put the function ee dot train dot slope. Okay, and call the image. Image mainly my dam data. Okay, so this slope is also created from the dam data. And further, I just clip with my study area, which is ROI. So now we can easily create the slope map. Just map dot add layer and put here that slope. Okay, click to the run. So now it represented the slope map. We can easily get it. It looked like black color. I want to stressing for visualization. Suppose I put at this stressing 98%. So now we can get the different types of angle. Suppose I simply apply, then you can see we can get this type of map. Okay, so in this time you can see we can get this type of map, white and black. I don't put any types of color. So default, we find out this type of color, white and black. So this type of white color indicating about that high slope area. Okay. If I click on here, you can get the result. You can see we find out that 2.09 degree. Okay. So this is the 2.09 degree angle created from the sea level. Find out. So if I add the color, suppose I put the color low slope blue color, then I show suppose this type of green color. I want to show suppose this type of yellow, and high slope I want to show as a red color. Red color indicating about the high slope area. Okay, so now you can got this type of result. So basically this type of red color indicating about that high slope area for your study area. Okay, because it's a hilly area, that's why you can find out that high slope. So for that, just simply import and then copy this variable name and paste after the object name, and then put the layer name slope. Okay, so this is our another factory created, and further we need that aspect. The aspect is mainly indicating the flow direction. Okay, suppose flow direction, it indicating the slope flow direction. Just I take a variable, suppose aspect, and put here e dot train dot aspect and call the image, and then further clip with our study area, which is ROI. So now just try to add the layer of aspect, map dot add layer aspect, click run. So now it creates the another factor for aspect. Okay, so now we can get this type of map here. You can see it's indicating about the flow direction. You can see we can get this type of map. Just I try to add the color for better visualization. Suppose I put this stressing 98%, and further we try to add the color. Suppose just put the color, suppose the same as suppose add the green blue, then put at that green, then put at that yellow, then put here was red. Okay, then further I just try to apply. So now we can get that this type of map which is indicating about our slope map, aspect map. Okay, aspect is indicating about the flow direction of inclination. Just import and further copy variable name and then paste here, and I put the layer name, suppose say aspect. So click run. So now you can get the three factor: name, slope, aspect. And you get the three layer. One is the aspect, then slope and name for our study area. Okay. So now we talk about that distance to road map or distance to river map. Okay. Suppose here you can see it's one kind of map. I already create for whole country boundary of Bangladesh. So basically this map called the distance to river map. Okay. Distance to river map, it means that how much close the river. Okay, how much close or how much near to the river. So here you can see this type of blue color indicating about the very close to the river. Okay, this type of blue color indicating about the very close to the river. And this type of red color, you can see this type of red color indicating about that much more distance from the river. Okay, it's the high distance, including the high distance. This type of red color indicating about that. So it's one kind of distance to river map, because it's also important for the future prediction of land use land cover, because people always try to make their settlement or try to make their household not near to the river. They are also always try to make the for distance from river. Okay, distance from river. They are also try to make their household or others. So this is the tendency of the people. So that's why it's also need for that create the distance road map. So now we try to create this type of map, and in this case, I try to use dataset. This dataset is the hydroshed dataset. We try to add in here hydroshed. So let me just simply copy the same code and try to use it, and then to the result. Let us simply copy. This is our distance river. Just paste here. So in this case, I just take this type of variable and I simply click with my study area, which is ROI. Click ROI. ROI. Try to add here the parameter. Okay, remove that. So now try to check the result first. Okay, so here you can see we can got this type of result. So basically for this place, it show about the river. Suppose here you can see distance to river and river network. So you can see distance to river. We can got this type of distance. So basically this type of line, you can see this type of line indicating about the river. Okay, it's indicating about the river.
So how can we extract this map?
Okay, in this time we are just use data set. You can see this data set called the hydrosheds data. So this hydroshade data provide you the data set, basically river data set or this data set you can see. Then we can get the hydroshades. The mapping product provide the hydrographic information for regional global scale application consists the format. So from this data set, we can easily find out that a river network or river different types of river we can easily find out using this data set. So drainage direction, okay, provide that. So now we can get this type of data from this line. It's indicating about the river. So now from here, try to create the distance road distance to river map. Okay, suppose I just on here, just click on here, and further we try to add the color. It also more better. Suppose I just 98%. So now I want to add the color. Suppose near distance to river, I want to show as a blue color. Near distance to river, show the blue color. Later then I want to show suppose this type of green color. Later then I want to show this type of yellow color. And far from the river, I will want to show this type of red color. So this red indicating the far distance from the river. Okay, I want to display this type of color and apply. So now this map display the result distance to road map. So here you can see you can get this type of map. This type of red color indicating about that far distance from the river, and this type of blue color it's indicating about the near, very near to the river. This type of yellow color or green color indicating about that medium. Okay, and this type of red color show about that high distance or high far from the river. So this is the your distance to river map. We can easily create from hydroshade data. So now further click on the import and copy this variable name. Just simply copy and paste after the object name. Just I paste here. Just paste here. Okay. So now it represented the distance river map for your study area. So not only for that, we also need the distance to road map. This is the distance to river map, and we also need the distance to road map. So that's why we also need the road shape file or your road line. Suppose in this study area, we find out the major road. Major road we need to find out, and then we can easily create the distance to road map. In this case, river network is not need. I just simply told that it's not need. It's just we need the distance to road map. Okay. So now we can easily create distance to road map. So now we try to create the distance to road map. Okay. It's a river map. We need to create the distance to road map. Okay. So for that, first of all, we have to check the data. Suppose we have already have, suppose I try to open this map result first. Okay, so distance to road map is not available. Okay, so we have to find out the road shape file for your study area. Okay, then we create the distance to road map. So because this data set is not available in the Google Earth Engine for the road shape file. So problem. So road data, hydroshed. So road data set is only available for US or United States. In United States, it's available for the road data. But so further, we also need to manage the road data. So let me try to download the road data for India, and then we try to use it. Suppose I search here natural art data. The natural art data. The road shape file, or I search here road shape file for India Central Road Open Screen. We try to the data from page is not found. Download free shapefile layers of India. Down latest. Download the building shapefile of India. Download the land use natural. Download the road shapefile of India. So we need the road. Okay. So we try to put here road and railway file. Just try to just download anyway. So from here we can easily get the data for road and railway. Okay, road and railway shape file. We can get it from that. Further, we can easily use it Google Earth Engine and create the roads distance road map. It's downloaded.
Sir, how can we export the LULC images of 2014 and 2024?
Okay, so for exporting, we are mainly using the GeoTIFF format. We can export Google Earth Engine, and further we can easily use the ArcMap or QGIS software, create the map. Suppose okay, map.
Before coding in which we are producing the LULC 2014 and LULC 2024, the map that we are getting from the coding in the previous code,
Yes, yes,
through,
previous code.
through previous code, can we extract the map from there and then save it in the format that you are saying?
So which format you want to export?
GeoTIFF you are saying.
Yeah, yeah. So we try to okay. So here you can see we already imported this two file. This is the GeoTIFF file. Port in here.
Yes, yes.
Okay. So
How?
this is our previous work. Okay. Basically this code, which here we created the two map land use land cover for this year 2014 and 2024.
Yes.
Okay. So these two land use land cover map I simply export from here as a geotip.
How can
Export
you
as
how is export?
okay. So for exporting, I already write the code in here. So basically here you can see the two code I write in here. Exporting, and I want to export it in my asset tab. Okay, so this is my asset tab. You can see
Sir,
asset tab.
this code is not in my code.
No, no, it's not your code. Okay, just I try to add in here extra code.
Okay. So how can I add this particular code in my code?
Okay, then further run the code after adding this code, and then our task tab will be running. We
Okay.
can see this tab will be running.
Uh, you give me this code for export.
Okay, I will
You
send
give
you.
this.
Okay, so now you can see it will be added the one. So further, just click on the run. Just click on the run.
Is done by the QGIS software,
Yeah, 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 yeah,
but we are doing in on the Google Earth engine, so it is new.
yeah,
New
yeah.
one.
Yeah, but our factory is the same. Okay, suppose you also try to check the not only for the one paper, try to also check the other paper. These types of factor they are used. Okay? These types of factor mainly influence to the land use, land cover change. Then you can easily get it. So if you want, you can also add the more factor, and it's also more better. But basically, this type of factor, then slope, aspect, this type of things we have to use.
Okay. Okay.
Okay, it's done. So, da-da-da. Right. Here you can see we can get the road and also get about that railway. Basically, we try to focus on the road, get the distance to road. So now we try to import this file on our Google Earth engine. Let's go. Clicking on the asset tab on the new. Here you can see this file, source file, and further just try to import file. Basically, we need that SSV, SSX, CAP, and PRJ. For file, I simply select and open. And I put this. It's a yeah roads. You can put any name. I simply upload it. So I can say our task will be running. So now it uploaded in our Google Earth engine. Now it's uploading. Fine. And we also need the population data. So do you have any population data for this or census data, or the more better than basically in the Jaipur we find out that this type of thing. The one is that Kowada, you can find out the Shapura, Manaharpur. So this type of place, how much people live? This information is also need. Suppose against the rainfall. Actually, we have this type of boundary. How much area? Suppose it's one kind of boundary. So this boundary, how much people? This boundary, how much people? Okay. Boundary, how much people? Boundary, how much people? If you have, then it will more better. In. Or we also get some population data from that. Suppose that's here. So here you can also find out some population data. World population global. So this data set I want to use. But this data set year of 2000 to 2021. So it's not provide the update data. It's 2020, 2022, 1. Okay? 20 to 21. But if you want to create the more accurate map, then we also need that actual data of population. Try to add this data and check the result what happened. But you also try if you have this type of place data or also this type of boundary. Suppose you can see this. This is the Pota, Poata, or Shahpura, or Manaharpur. This type of region to have the boundary as well as if you have this number of population, then it also more better. So let me try to add this data. So it's not the update data. It's 2020. Find out that. Just I try to import it. Just I start the data. Suppose I put this name. Pop will pop. Call this image collection and paste here. So now I just try to simply create the select function and select this band. So basically here you can see this as a band. This band is the population. Copy. There. When I put this there, I was filtered that. I put this time, latest time is available from 2021. So just I put the 2021. First from 2001 for 31. And further I create this in population, average population between time we create. And this mean just simply keep with your study area, we see RO. So now we try to add there. We just put a variable map dot add here and put here the population. Just click the run. So now it added the another layer. Copy. And there for population. So there is no. Let me try to increase the time. Suppose 2000, 2020.
Sir, this is image collection of 2021.
Yes, the image collection. So now we can get this type of map here. You can see. So basically, dataset is not updated dataset. That's why have the ground data. Suppose ground census data, then it will be more better. So in this time we can get this type of map for this population. So basically, here we find out that type of white color. We find out that the population density is the high of white color. So this type of region is the population density is the high type of region. Okay. Type of region. Find out that high density of population. We can also add the color. Suppose I add the color. Suppose I want to show here is the low population. It shows about type of color. Then high type of. Then high show this type of blue color, and very high so as a just try to. So now you find out this type of map. Here you can see. So this type of region, we find out that very high density of population. And others, it also this type of indicating about the low, not mass. But this we find out that high because it is cities. Find out the high, and others is the hilly region. We find out the low. Just I try to import and further copy from name. And so now we can get the another factor for population density. Where is the high density? Where is the low density? We can easily find out this map. We get the result. Where is the high density? Where is the low? Find out. So now I create. So now I create only for the one layer, then roads uploaded. So basically, it's very all of there's a lot of load for the whole India boundary. So that's why it takes some time for importing running. So now I can create this type of layer here. You can see one is that distance to river map. So it represents the distance to river map, and also you can see on another is the population density. Okay? So this one is the population density map for your study. We can get this type of map, population density, and this one is the aspect map. This one is the slope map. This one is the dam map or elevation map. So dam, then slope, then aspect, then population density, then distance.
Okay.
Okay. And further, we also make the distance road map. So basically, when I create this type of factor, we can easily as the input in our machine learning model, and then we can easily predict for the future. Okay, not only for that, it also including the two land use land cover factor also, which we already created for the land use land cover 2014 and 2024. We also input. Then from here you can find out that future prediction map of land use land cover for.
Uh, After produce this output, uh, how can we use this output in prediction?
Basically, we find out that prediction land use land cover map, as well as we also get about the change number, change land use land cover change area. So further, we can get this type of map. Let's suppose we can easily find out that the what's the changes in 2000, suppose 2000 in 2034. Okay? 2034, what the changes? You can easily find out that from this land use land cover prediction map. Okay? We find out that which area is the increasing, which area is the decreasing, as well as also get about that land use land cover areas, okay? And also get about the accuracy about our prediction model. So this type of data we can easily generate from.
Okay, sir, we export two LULC 2014 and 2024, but in this particular map there is only one map is showing.
Yeah, so it's show only for the one layer, but it's about that you can see. Just we uncheck it, then other layer is also open.
But where these particular shapefile goes, which we are export for 2014 and 2024,
Yeah,
where
continue.
these two shapefile goes, where we use these particular. Then after that, there is only one map is there. We merge those particular two maps of 2014 and 2024. We merge those maps.
In your asset tab,
No, I want to ask that we export two images, two geotab images for 2014 and 2024.
yes, yes.
But in this particular map, there is only one image is showing, which is from Jaipur, which is for Jaipur. So we merge those shape files to the 14 and 2024. Uh,
Not yet now. So this time it's just different. Suppose it's the one map, another is the another map. The two map we already generated from other code, and then further we export the two map, individual two map.
we have to do slope dam for separate 2014 and 2024
No, no,
separately.
no, 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 no. Because them is captured only for the one time, one imagery. We the same imagery. But this type of factor is just only for the one time, not for the 2014 or
Uh,
2024.
it's okay, but I want to ask that when we export two images, then how can we get one image?
I don't understand.
Uh, Means 2014 and 2024 are two maps, two shape files, and this is showing the one map. So in coding in this particular line of code, where we are going to merge, or when we are going to uh, combine those particular images for
In this case,
14.
there you can see our input data. In this
Okay.
input data, we try to import full land use land cover map
Okay.
and also
o-
dim, slope, aspect, distance, but distance water body map. This
okay.
dim, slope, aspect, distance, road, distance, but there is no relation with the land use land cover map. It's totally separate map
Okay. Okay.
for
Okay.
this study area.
Okay.
So in this time, we already created two.
Just we export those particular shape files.
Yeah, yeah. This case, we
Okay.
already created the two detailed land use land cover map, and now we also created them slope this type of factor. And for that this type of factor, we are just applying the machine learning model in Earth Engine. So in this case, they are using the Molas plugin. So in this time, we are not using the QGIS software. We are just applying that land use land cover using machine learning in Google Earth Engine, and we computation of the area of change,
Okay.
then make the prediction.
Okay. Okay. So now what we are doing?
So now our your shapefile is imported. You can, because it's a very long area. We try to imported the full shape file, road shape file in the whole India boundary. That's why it loaded takes some time to loading.
We are importing the India's road
Yeah, yeah.
okay.
So here's I downloaded
Okay.
and
Okay.
further we try to import it and it's working. Okay, so loading. You can see about that your land use land cover. It's a show this type of thing. You can find out the 0 to 3 and 30-meter our scale. So if you want, you also visualize this land use land cover map also in code. Suppose I want to add the layer of land use land cover map code. So for that, we are simply here write the code in here. Just like call map dot add here and call the LULC 2024 because I take the name. Name is that LULC 2024. Just I copy the name and the same name a layer. So then this map layer is also added for this. Okay, just paste here. And further we try to add the color. So I simply copy the color from previous code. Color code from here. copy. So just I put here the 3, the 0, 1, 2, 3. You can get the 4 classes. So just do link. So great. So now try to add the second layer. Put at the 14 and I put the layer name 2014. So now this full land use and cover map is also added or here added. So now we also input the two land use land cover map 2014 to 2020. Find out this. But this two map we export from another code. And now we are just using map in our prediction code. Okay. Now just try to get this working. It takes some time because it's the whole boundary of India shapefile boundary. So that's it takes some time. But if you want, you can also apply the another way. So try to open software. Then open this file. Then try to click boundary.
And now what we are doing?
Okay, so it loaded. You can see here. That loaded this boundary shape file in Google thingy.
So we also have to use QGIS.
So it's not the part of this work. So I let me the shape file from long shape file. Just we just clip only your study area Jaipur, then it very
The
for time. Time it uploaded for whole India country boundary. That's why it take much time for uploading.
okay, 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 sir. No problem, sir.
The whole country of India road. It's only indicating about the road shape file for the whole
Okay,
India country boundary.
okay,
But
okay, okay, okay.
that's it take some time. It is possible to clip then only for the Jaipur boundary. Also get from the road easily. For me, just there's a lot. 21 lakh 685 total road or feature. 21,11,685. I think it take the more time. So okay, so I will complete only for the one layer, and after that I send you this. Okay. Oh, done. Okay, thanks. So now I try to show you that. So you can see when it's done, simply refresh. Just simply refresh it. So now you can see we can get that India roads one layer added in my asset tab because it just further simply copy, just import in here. You can see imported the table to India roads. We can easily get it from here. Further, you can simply use import from here. I simply copy and then put in here roads. I put this variable name as a roads here to use. And further we try to click to the run. So now our can click the shapefile. Shapefile name is that the AOI. I just after the below of ROI. ROI. So now click run. It's working now. Basically this tends to board layer the distance generated here. So now further we can simply click on here and then we can easily make the map look like that, just my 8%. And further we just apply the different types of color. Okay, then further I simply let me add the color first. So let me add the near to the road. I want to show this type of post. I want to show some of this type of white color. It's indicating about the near to the road. Okay, and get at then I want to show this type of some color. Get at then I want to show suppose you color and far from road. Okay, more far from road to the red color. It's indicating about that more distance from the road. Just try to apply. You can get this type of things, type of maps. Here you can see near to the road. We find out this type of white color indicating about the near to the road. I guess we can get it type of map. So this type of white color identify about the near to the road. Okay, and this type of red color indicating about the distance from road, more distance from road. Okay, white color indicating about the near to the road. We can get, so this is the map for distance to road map. We can use it for our input. Just simply click on the import and copy this variable name and then set with our code. We set with our layer. Then we simply prepare distance to road. Just I set in here. Yes, let me say. Now further click to the run. So now we got all of our parameter factor. Now we can easily apply the machine learning model and use type of factor as the input, and then we can easily predict for the land use and cover classification factor. So mainly here you can see all of vector we try to add in here. One is that distance to river. Then we try to add here land use land cover 2014, which we already created. Then land use land cover 24, we already created. You can see all of layer. Try to add in here. So further, this type of vector we can simply apply in Google Earth Engine. It's a distance to river map. We can get it. This is the map for LULC 2014. This is the map for 2024. We find out. Then we find out that population density. The population density. Then we find out that aspect map. Then we find out that slope map. Then we find out the dam map, and finally we find out the distance map. So
Okay.
basically, this type of factor, one you can also read more paper, and then if you have any other factor, you can, and further we also try to use it. Such as one factor is called restricted area. Restricted area mainly it can be airport or it can be cantonment area. So it's also we can also include as a factor, okay, as a restricted area. So if that region have any cantonment or any airport, so if you want, you can also add it this type of factor, okay? Because it also influence for land use land cover changes. So you try to add the more factor, suppose which are mainly responsible for change the land use land cover classification, such as restricted area in the cantonment. In the cantonment, anyone cannot set up their settlement, or it's really restricted area. There it not change for there any construction or other things not be changed. So if you want, you can also add the another factor for restricted area, or if you want, you can also add for any other region or suppose airport or any other specific factor. If you have, you also try to add. So basically, commonly this type of factor we are also used to create for one land use land cover prediction. The common factor type of factor is applicable for any kinds of land use land cover future prediction map.
Sir,
Yeah.
sir, can we use a factor which is not used yet in any other work which we introduce in this particular work? Is it any factor? Can we introduce any factor which is totally not used by others, but we can use this? We
Which
use
which
it this.
which factor? What's the name?
I don't know which factor. I am asking. Just I am asking. Uh,
Okay, so
I am asking because these are the factors that you are showing are are useful and are used in this particular project.
yeah.
But one particular factor which is not used by anyone, and we are using in our project.
Okay, so for that one you can also try to add. So basically, for the land use land cover, to have the crop change future prediction, then you also add some climate data, because crop is also responsible for that climate data. But in this, put that um, land use land cover was aspect map, hillside map, or population density, scope, distance to road, distance to river, or distance to railway. Basically, this type of common things were used for prediction. Mainly,
Okay.
all of paper are used only for this factor. But if
Okay.
you try at the more factor, such as distance to airport, distance to cantonment, distance to any other place
Okay.
for influence map. So in this time, it's just for that, not for the crop classification. Then we also try to add the other types of vegetation indices as a factor. But in this time, it's a normal land use land cover classification. That's why I think not need to add the other indices such as NDVI, NWI. It's not need. Type of factor is also okay. And further, for the agriculture or crop land prediction, we also need to predict for the climatic data. Suppose We are just use the time series, and then further we try to predict for this. Suppose I want to make the crop classification prediction for year of 2034. So for that, I also need the climatic data for 2034. So that's why we also need to predict what is the rainfall data in 2034, what is the what the temperature data for 2034. We need to predict. But in this case, we cannot predict for the crop classification. So that's why it's not need to add.
Okay, okay,
Okay, so I will send you this code link and also send you the paper. In the meantime, you also try to read this paper. Not only for that, you also try to read the other paper also, and then
okay,
further you also try to read the code. Then we can easily apply this code for the next class to make the future prediction for the land use land cover 2034, and then we can easily make the land use land cover prediction.
okay,
Okay, so today is no more. I will send you the code. You also try to check it. Also check the other paper also for the land use land cover prediction using the technique. Then we also try to explore the more things.
okay.
Okay,
Which code you sending?
I will send you this code.
This code. Okay.
The right code. Okay.